What's up, everybody? Today we're going to go old school and we are going to be talking about rational numbers. Now, you might be curious as to what a rational number is, and it's not too bad. Really, it's any number that you can write out as a fraction, right? So it's any number that we can write out as a over b, right? Assuming, of course, that our denominator is not 0, because if you have any number over 0, it's undefined, right? So for a few examples of irrational numbers, we could have 2/3. How about 11 over 3? How about -5 over 9? You could even have, I don't know, how about 17 over 22? Just making up some stuff here. Okay. Now, sometimes these have special names and sometimes they don't. For instance, here, if you notice this 2 over 3, right? This is where the denominator is actually bigger than the numerator, right? So this is called a proper fraction, right? So that's when you have the smaller number in the numerator, right? So a proper fraction is a smaller number over a larger number, right? As opposed to something like this, 11 over 3. That's called an improper number, right? And it's improper because we have the larger number up top in the numerator over the smaller number. So if you look at -5 over 9, if you ignore the minus sign, it's not too important in terms of proper or improper. Just look at the numbers themselves. You have a 5 up top and a 9 down below, so that's a proper number. And 17 over 22, since you have the bigger number in the denominator, the smaller number in the numerator, that's called a proper integer as well. A proper rational number as well. What we're going to do today is, again, like I said, we're going to go old school. We're going to talk about ways we can add, subtract, multiply, divide, reduce, do all kinds of operations, because this is going to set up for the idea of rational functions, which we're going to be hitting pretty soon. But I wanted us to review to remind ourselves exactly how we're going to be doing these things. Okay? So let me give you just a couple of more words here to use here. Instead of proper or improper, we can also have what's called a mixed number. Right? A mixed number is a number that has an integer, right, plus a proper fraction. These things look like 3 1/3, right? Or maybe 2 and 17/18, or maybe -6 and 3/5. Right? Now, when you read these, be careful. This isn't an exponent, right? This is just another number. So we should probably write it as -6 with the 3/5 right next to it. And it's assumed that there's a plus in between there. Okay? The way we can go back and forth from these things isn't too bad. For instance, let's say I have this mixed number, right, of 3 and 2/5. Okay. The way we can think about this is to get a common denominator and put it all together, right? So this is the same thing as 3 over 1 plus 2/5. Right? If we get a common denominator, I could take this 3 over 1 that we've got, right, and multiply it by 5 over 5. And then what I'm going to have is 15 over 5 plus 2 over 5, which equals 17 over 5, right? Which, if you remember, is an example of an improper fraction. So if you ever go from a mixed fraction to one of these, it's always going to be improper, because that whole number that we've got right here, that's going to add too much to the numerator and always make that numerator bigger than your denominator. So when we go from mixed to a fraction, it's always going to wind up being an improper fraction. All right? So let's check out one more of these things. What if I had 9 and 3/7? What's that going to be? So this is the same thing again as 9 plus 3/7. So what I can do is again get a common denominator by multiplying this one by 7 over 7. Okay? And then when we do that, what we're going to have is 63 over 7 plus 3 over 7, which adds together to give me 66 over 7. Okay. We can work backwards as well. Right? This is how we go from a mixed number to an improper fraction. Here's how we can go the other direction, where if I start with an improper, I can wind back up at the mixed. Right? So here is an improper number here. How about 19 over 4? Right? The way we can figure this out is I can just take 19 and divide that by 4. Right? 4 goes into 19 4 times. 4 times 4 gives me 16, so my remainder is 3. So this is the same thing as my dividend right here, 4, plus my remainder over my divisor. Right? So that just gives me the mixed number of 4 3/4. Right? For another example, let's look at, how about 137 over 11? What's that going to be as an improper number? Well, let's take 11, divide that into 137. Let's see, 11 goes into 13 one time. And then I subtract those. 3 minus 1 gives me 2. Pull down my 7. 11 goes into 27 2 times. 11 times 2 is 22. And I get a remainder of 5. Okay. So again, this is going to equal my dividend 12, right, plus my remainder 5 over my divisor 11. So this is just 12 plus 5 elevenths, which we can write as 12 and 5 elevenths. Okay. And be a little careful, because depending on how you write this, somebody might look at that and say, ooh, that's 125 over 11, right? Because that's kind of how it looks right there if you look at it kind of funky. So when you write these things out, remember to put that little space in there or write it a little bit smaller or something, just so it's fairly obvious what that number is. All right, so those are the 3 types of rational numbers we're going to play around with today: proper, mixed, and improper. Okay? So let's go on into these operations. Right? And the first one we're going to talk about, we've already done a little bit, and that's adding and subtracting these fractions. Okay? Remember, what you have to have here is a common denominator. All right, if you have a common denominator, then this is a piece of cake. Right? So if I had 11 over 7 minus 5 over 7, then that just gives me 6 over 7. Right? Remember, our denominator doesn't change. Right? It's still going to be 7, but that 6 comes from this 11 minus 5 part. Okay? So if I had 72 over 37 plus 16 over 37, we already have a common denominator of 37, and 72 plus 16 gives me 88. So again, in order to add and subtract any fraction, you have to have a common denominator. Right? So luckily, all of these had a common denominator of 37. Okay? So what if we don't have a common denominator? For instance, 7 over 2 plus, just kidding, 11 over 6. Okay. All right. Well, obviously we have to get a common denominator. And there's things which are called common denominators and least common denominators. No matter which method you use, you'll get to the same answer when you simplify it all the way down. But if you want to make your life easiest, then what you want to use is your least common denominator. Right? So let's do it both ways so you can see. Right? So let's work with our common denominator first. So if I had 7 over 2 plus 11 over 6, one thing you can always do is just to multiply by every denominator you see. So for instance, this first term has a denominator of 2, but we need a 6. So I could multiply that one by 6 over 6. Okay? And this second one has a denominator of 6, so I could multiply that one by a 2 over 2. Okay? And if we do that, I will get 7 times 6 is 42 over 12. 11 times 2 is 22 over 12. And that will add together to give me 64 over 12. Right? Which, if you notice the top and the bottom, we could divide everything through by a 2, which would give me 32 over 6. I can divide by 2 again to give me 16 over 3. Okay? All right, so that's what our answer is going to be here. What happens if we had just used our least common denominator? So if I have 7 over 2 plus 11 over 6, well, I notice if I just take 2 times 3, that gives me 6. So let's multiply this one by 3 over 3. Okay? And then we'll have our common denominator of 6 and 6 there. So 7 times 3 is 21, plus 11 over 6 gives me 32 over 6. And if you divide the top and bottom by 2, you get 16 over 3. So it saved us a little bit of a step because we used our least common denominator. But you'll see we did get the exact same answer. So again, whichever way you want to do it is great. But I promise you, especially when we start working with these rational functions, the least common denominator is the one that you're going to want to use because it will help you out quite a bit down the road. All right, so again, for adding and subtracting, look for that least common denominator or that least common multiple, and that will help speed up the process. So for subtracting, just for a couple other examples, if I had 19 over 3 minus 1/5, I could multiply this one by a 5 over 5, multiply this one by a 3 over 3, and let's see, 5 times 19 gives me a 95 over 15, minus 3 times 1 is 3 over 15, and this gives me 92 over 15. Right? And if you want to write this out as an improper fraction, as a mixed fraction, remember we could take 15, divide that into 92. Let's see, 15 times 6 gives me a 90 with a remainder of 2. So this is the same thing as 6 and 2/15. Okay? So there is your improper answer, and this is your mixed answer. Right? So when you're doing the homework, make sure you read through the problems to see which style they want you to do. If they say leave it improper, you're done right here. If they say put it in mixed, then you have to simplify it a little bit more. All right, here's another one for you. What if I had 2 and 2/3 plus 3 and 1/4? All right, well, let's turn these into some improper fractions and go from there. So 2 and 2/3, remember that's 2 plus 2/3? And if I get a common denominator here of 3, I can multiply the top by 3 over 3. And this will give me 6 over 3 plus 2 over 3, which is 8/3. And then here, 3 plus 1/4, I can do the same thing, but multiply this one by a 4 over 4, which will then give me 12 over 4 plus 1 over 4, which then turns this into 13 over 4. Right? So now if I want to combine these two together, I have to get a common denominator. So for my least common denominator here, let's see, for the powers of 3, I can go 3, 6, 9, 12, 15, 18, and so on. For 4, I've got 4, 8, 12, and ding, 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 there is my winner. So 12 is my least common denominator. So what I'll do is I will multiply this one by 4 over 4, this one by 3 over 3, and then now I have 32 over 12 plus 39 over 12, which gives me 71 over 12, right? Which reduces to 5 and 11/12. Right? So see if you can finish that one off to get that mixed number. All right, so again, the key for adding and subtracting fractions, if you have two proper or improper fractions, get common denominators. If you have a mixed problem, like you do here with these mixed numbers, turn them into fractions, get your common denominators, and then add them together to finish off the problem. All right. Let's go into the idea of multiplying fractions. And again, this is pretty easy. I like that space in there. It's multiplying fractions. All right. So if I had the fraction 7 over 2 times 11 over 6, the way you multiply these is you just multiply straight across the top and straight across the bottom. Right? So this becomes 7 times 11 over 2 times 6, which is 77 over 12, right? Which breaks down into 6 and 5/12. All right, what if I had 19 over 3 times 1/5? Again, multiply straight across the top to get 19 times 1, straight across the bottom to get 3 times 5. So that's 19 over 15. It's an improper fraction, and that's the same thing as 1 and 4/15. All right. What about 2 and 2/3 times 3 and 1/4? Well, we don't have to worry about common denominators here, but let's turn these into improper fractions, right? So 2 and 2/3, if you remember from the previous page, that's the same thing as 8 over 3. Right? 3 and 1/4 is the same thing as 13 over 4. So what happens now if we multiply these two things together? Right? Well, again, if you just go straight across, you'll get 8 times 13 over 3 times 4. Okay. All right. And then if you multiply this out, 8 times 13 is 80, plus 24 is 104 over 12, okay, which is the same thing as 8 and 8/12, or 8 and 2/3. All right, so again, for multiplying fractions, do not care at all about the common denominators, right? So all you have to do is multiply straight across the top and straight across the bottom. So proper and improper, easy enough, just go straight away. If you have mixed numbers in there, turn them into these proper and improper fractions, and then go on and do your work. All right, what about the next operation? Right? What happens if we want to divide rational numbers? Right? In other words, if I had 3/4 divided by 5/7. Well, again, if you remember dividing by fractions from your high school days, this is the same thing as 3 over 4 times 7 over 5. And now with multiplication, remember we can go straight across the top and multiply, and straight across the bottom and multiply. Right? What if I had 7 over 2 divided by 11 over 6? Well, again, take that second term, flip it, and multiply, and we get 42 over 22, which is the same thing as 1 and 20/22, right? Which is the same thing as 1 and 10/11. Right? Another way you can think about division is actually as a fraction. Right? If I had 7 over 2 over 11 over 6, remember a fraction, all it is just the division problem. It's just the numerator divided by my denominator. So this is the same thing as 7 over 2 divided by 11 over 6, which gives me 7 over 2 times 6 over 11, which gives me my 42 over 22 number, which again is my 1 and 10/11 that we saw just a second ago. Right? So if you ever have one fraction over another, flip them and multiply it. Okay, so if I had 2 over 11 divided by 13 over 17, then what you can do is take that numerator, divide it by the denominator, and when you divide by that denominator, again, what we're doing is we are going to flip it and multiply. Right? So 2 times 17 gives me a 34, and 11 times 13 is 143. Okay? So there is that particular division problem. All right. By the way, if we use positives and negatives, you may have to keep track of that. If I have a negative 2/3 times 4 over negative 7, then this gives me a negative 8 over negative 21, and a negative over a negative makes it a positive, so it'd just be 8 over 21. If I had negative 1/5 times 11 over 6, then if you multiply straight across, you get negative 11 over 30. We just have one negative in here, so we can't cancel anything off, so that's what we've got, negative 11 over 30. If I had, how about 2 over 11 divided by 5/8? How about a negative 5/8? Then that's the same thing as 2 over 11 times 8 over negative 5, which gives me 16 over negative 55. And if you just have one negative sign in there, that's the same thing as negative 16 over 55. All right, so just be a little careful with your positives and negatives when you are multiplying and dividing. All right. Now, the last thing we're going to talk about doing with fractions is reducing fractions. All right, so again, what if I had 28 over 38? All right. What we're going to do is we're going to reduce using the greatest common factor. Right? Or even if you just use common factors and pull them out one at a time, that'll work fine. But if you use the greatest common factor right off the bat, it'll just be one step and that's it. If you just keep on pulling out common factors, it might take 2 or 3 steps, but you'll still get to the same spot. For instance, if you look at this, they're both even numbers. So I know I can divide by a 2. So that gives me a 14 over 19. Right? And now they have nothing in common, so I'm done. Right? So in this case, the greatest common factor, or as the cool kids say, the GCF, was 2. Right? What if I have 66 over, how about 24? Right? Well, we can just keep on dividing things out here. For instance, I could divide both the top and bottom by a 2 to get 33 over 12. But then the top and bottom are also divisible by a 3, so that makes it 11 over 4. And now they have nothing more in common that we can cancel off. Right? So here we just pulled out common factors. Right? The common factor from here to here was a 2, and the common factor from here to here was a 3. Right? Now, if you look at the greatest common factor, though, the GCF for 66 and 24, that happens to be the number 6. So if I notice that right off the bat, what I could have done is I could have divided the top by 6 to get 11, divide the bottom by 6 to get 4, and boom, we did it in one step, right, as opposed to multiple steps. Right? So again, dividing by the common factor is okay. It'll get you to where you need to go, just like we did here. But if you divide by the greatest common factor, then you just do it in one step. Right? So the common factor is multiple steps. Greatest common factor is one step. Right? So I guess the obvious question here is, how do you find that greatest common factor? Well, if we look at 66 and 24, how do these things factor? For instance, 66 is 33 times 2. 33 is 11 times 3. So 66 equals 2 times 3 times 11. Right? 24, that's the same thing as 6 times 4. 6 is 3 times 2, and 4 is 2 times 2. So 24 equals 3 times 2 times 2 times 2. Right? So if you're looking for common factors, they both have a 2 in them, and they both have a 3 in them. Right? So what we can do is we can combine these together and say the GCF, the greatest common factor, is equal to 6. All right, let's do one more of these things. If I gave you the number, how about 98 and 28? What's our greatest common factors here? Well, 98, it's even, so I can pull out a 2. So that's 2 times 49. And then 49 is 7 times 7. So 98 equals 2 times 7 times 7. 28, that is 7 times 4. And 4 is 2 times 2. So 28 equals 2 times 2 times 7. Okay? So for the greatest common factors, they both have a 2. And they both have a 7. So here, the GCF is just 2 times 7, or 14. Okay. So if I gave you the fraction 28 over 98, we could divide the top and bottom by 14 to get 2 over 7. And then we'd be done, right? Because there's nothing else we can divide by. All right, so that's it. We are going to be working on these rational numbers. I know a lot of this is review, so just bear with me. A lot of these skills we're going to work with are going to translate over to rational functions when we start adding things such as, how about 1 over x plus 2 plus 3x over x minus 5? Right? How do we have to add that together? Same thing we did before. We need to find common denominators and move on from there. So let's build up these skills to get back to where they need to be. We'll apply them to this stuff, And then after that, we will hop all over these rational functions and we'll really start rocking. All right. So I hope you guys enjoyed. I will see you in class.